atomic mass unit. Why do we even need such kind of a unit? Just think that you're given a metal ball and a needle. The metal ball is the heavier object and the needle is the light object. Now your task is to measure the mass of the needle with respect to the metal ball. Now think that you are given just one metal ball and one needle. What we can do is put the metal ball and the needle on a balance, and your balance will look like this. The metal ball is much heavier, and because of that it is harder to measure the mass of this needle with respect to this metal ball as it is. So how can we proceed with this? Something we can do is that we can take this metal ball out and then we can crush it into metal powder. Once we crush it into metal powder, we can take a small scoop of metal powder and place it in the balance. With the help of this metal powder, now we can finally measure the mass of this needle. So what does this example mean? In order to measure the mass of a very small object, we need a suitable small measuring unit. Now when it comes for atoms, atoms are not visible to our naked eye and they are very small. And because of that, we need a suitable unit to measure its mass. And that is why we have developed this kind of a unit called atomic mass unit in order to measure the masses of atoms. The atomic mass unit has the standard units of AMU, standing for atomic mass unit, or we can use U. Atomic mass unit is defined as 1/12 of the mass of an atom of carbon-12. That means 1 U is carbon-12 atom divided by 12. I'm going to explain this in more simpler words. Let's say you bought a large pizza and now you are dividing it into equal pieces. 12 equal pieces. Once you cut this into 12 equal pieces, you take one slice out. If you want, you can call this slice of pizza as the standard pizza unit, and you can use this standard unit to measure the weight of other things. Let's say you want to measure the weight of a person. We can put that person on a balance like this, and on the other side we can load these standard pizza units on the other side until this get balanced. Atomic mass unit is also used in a similar manner. Think this as the carbon-12 atom, which we divided into 12 equal pieces, and this is the piece that we took out, which is 1/12 of the carbon atom, which we can identify as our unit, or 1 atomic mass unit, or 1 U. Now using this 1 U, we can compare the other atoms from other elements. For example, if we take hydrogen, we can compare the mass of hydrogen with respect to this U. We are going to find out that hydrogen is going to be 1.007 U. Let's try another atom, lithium. Lithium is going to be 6.941 U. Now I'm going to compare the atomic mass unit with grams. Here you can see exactly 12 grams of carbon from carbon-12 isotope. If we take this number of atoms, you know what this number is. This is the Avogadro's number. If we take an Avogadro number of carbon-12 atoms, it's going to weigh exactly 12 grams. So this many atoms weigh 12 grams. So we can easily find the mass of one carbon atom. How do we do that? We simply divide these 12 by the Avogadro number, which gives us the mass of one carbon atom. What you see here is the mass of one carbon atom. Now our definition for atomic mass unit is not one carbon atom, it's 1/12 of the carbon atom. So simply divide this number by 12 in order to find out 1/12 of the carbon atom, which is this number. So basically what this means is this is our one atomic mass unit or 1 unit. Now you can see one atomic mass unit is a very small gram value. All right, this is what we obtained from our previous calculation. Now let's take hydrogen atom as an example. The mass of hydrogen atom can be expressed in atomic mass units as 1.007 U. Also, we can express the mass of hydrogen atom in grams. Now think you are going to do a calculation. Which number is more easy to use, this or that? It is a lot easier to work with this unit, this number, than dealing with this scientific notation and these exponent values. Now this is the purpose of atomic mass unit.